Biomechanics are in every single sport. They examine forces acting on the body and the effects of these forces. By studying an athlete's performance, inadequacies that are limiting their performance can be diagnosed. The coach can then incorporate drills into the athlete's training to overcome these shortcomings. We are studying exactly this, analysing the biomechanics of our chosen event and working out the best way to improve our skills. I have chosen to do long jump, and during this speech I will focus on my analytical view of this skill, whilst referring to my study of comparison videos of a professional long jumper. As my skills are not always efficient, I have analysed the biomechanics of long jump. The major difference between my jump and the professional jump is that he has a much larger run-up and an extremely different jump. In the run-up of a long jumper, as known as the entry phase, a rhythm should be created to build speed during the approach. Somewhere between 4 to 6 total steps or 2 to 3 right steps are commonly used to accelerate to maximum speed, although this may change depending on the speed of the jumper. It is clear that in the comparison of the two videos, my run-up and time taken to attain full speed is a lot shorter than the professional, resulting in him having much faster max speed. This is because acceleration equals force divided by mass, and force was not of a high enough velocity. Therefore, I was not summing enough momentum. The professional's last 3 strides are considerably lower and longer than his other ones. He does this in preparation for the takeoff. In comparison, only my last 2 strides are considerably longer than the others, and unlike the professional jumper, they do not appear to be lower. The result of this is that my center of gravity did not become lower, so that I was not balanced or I did not have the right body height for my takeoff. This does not allow me to have enough force pushed into the ground, and therefore not enough force acting upon my body to be pushed upwards to give me an accelerated takeoff angle, as stated in Newton's third law of action and reaction. For every action, there is an equal and opposite reaction. The takeoff angle in my video looks to be slightly under 45 degrees, as opposed to the professional when he attains a much higher angle of takeoff, roughly estimated at 50 degrees. This allows him to jump higher, and combined with his impressive amount of horizontal force, he jumps extreme distances. The main focus of the landing is to overcome angular momentum. In my video, the landing shows my feet slide where I land, and I fall back to where my feet touch the sand. As ineffective as this is, I didn't lose any distance from where I first landed. When analysing this, it shows that I did not have enough momentum to push my body over my feet when they hit the sand. Surprisingly, the professional's landing is quite similar, although his center of gravity was pushed to one side, and he primarily used his hip and elbow to land instead of his lower back. This meaning that he had more momentum as he hit the ground. There are many easily interpreted errors in my long jump. To change this, I will need to alter my training techniques, focusing on my main errors and working on conditioning and skill-based training to improve them. I discovered that one of my early faults was that I didn't get a low enough center of gravity in the build-up to the leap during the final 2 or 3 steps. This will be improved on by using skill-based training whilst exercising practice leaps into the pit. Focusing on getting as low as practical in any effort to give my legs maximum thrust upwards during the jump, as stated in Newton's second law of motion, where he states that the acceleration of an object is directly proportional to the net force of the same direction, in the same direction as the net force. In this instant, my legs pushing against the ground upwards would be the net force. When the videos of the professional long jumper and I are put side by side on Dartfish, it is obvious that my force when I leap is much lower to the professionals. When force equals mass times acceleration. This means that I need to work on my acceleration to improve my force. I will do this by altering my conditioning routine so that I can improve my speed and strengthen my acceleration. To do this, I would need to engage in exercises such as single leg box jumps, sled pulls/pushes, and skipping. One of the best known results of the science of mechanics is that the optimum projection angle for achieving maximum horizontal range is 45. Unlike the professional's takeoff, mine is below the angle of 45 degrees. This means that I'm not getting the maximum jump as a result of my force. I can improve on this in skill-based training by jumping over boxes when practicing my long jump into the pit. This work will ensure that I attain a maximum height on my jump. Biomechanics is the study of actions and breaking down elements in every single physical action, as demonstrated in this presentation. Biomechanics can be used to analyze, design, improve, and make an effort in the improvement of the activity studied. I have learnt how to analyze and critique a training schedule and a long jump performance based on biomechanics. Throughout this unit, I believe my long jump has improved, although due to Newton's third law of acceleration of action and reaction, I still didn't produce enough force against the ground, and therefore I didn't get enough acting force on myself. I have examined the best way to improve on my jump through a series of conditioning exercises and skill-based training. Now I am able to work on my weaknesses in an effort to improve the effectiveness of my jump.